All right. Any questions about anything? Yeah.
Is there like an RNG bash command, like kind of in the sense with like C, or like randomly generates a number based on?
Oh, for random numbers, yes. But what might it be called? So the manual command, you can do say -K and look for a keyword, and it'll tell you anything that has that keyword in the first line description. So I did a man-K random, so I see something called shuff, which generates random permutations. And AGP is a password generator. And commands also have C alsos at the bottom. Which doesn't help us in this case. But I'm pretty sure there is.
I think it's that one that's random.
So if it has a 3 next to it in parentheses, that's something that you can call from, say, a C program. Right? So you could absolutely pretty easily write a C program that would print a random number, and then you could call that from Linux. But Bash has a built-in variable called random. So if I say echo $random, it gives me a random number each time. So yeah, that's the easiest way. Yeah.
Yesterday you mentioned something about when you log out of a session, all these variables, all the variables disappear.
Go away, yeah.
Could you explain that again?
Sure. So I'm on my machine, but it's going to be exactly the same thing on the Linux server. So let's say I have to use my home directory a lot, and I want to make a variable that I'm going to call homedir, which is equal to my home directory. So that's just a variable I've set up, or it could be whatever you want, right? Once I exit, if I go back in and I say, let's find the value of this variable, it doesn't exist anymore. Okay, when you create a variable and give it a value, when you use an alias statement, all of those things, they're temporary. And once you exit and you start a new login or a new bash, those things aren't there anymore. So what you can do is in your home directory, so if you just cd, which takes you to the directory you are in when you first log in, there's a file called .bashrc. And it'll look different for you, but this is what my bashrc looks like. And down here I could say something like homedir equals /user, or whatever it was that I wanted it to be. And every time that I log in, or every time that I start a bash shell, everything in this file gets executed. So it's going to act as if I had typed in this variable assignment. So now, next time that I start a shell, if I say echo $homedir, it's got the value that I wanted. So all those things, all those shortcuts, aliases, variables, things like that, you can put them in bashrc. Yeah?
Can you show that BI stuff bash?
So the file name is .bashrc. And a lot of commands in Linux have initialization files that go along with them, and the initialization files usually end with the letters RC. So like there's an editor called EX that kind of sits underneath VI. There's a file called .exrc which lets you set up initial commands for the editor. All right, good. Other questions? All right, so let's dig deeper into scripts. I guess I'm going to call it go. So I'm going to write a bash script, and it's going to say echo hello. Oh, so something I saw on the latest ODP, because when you assess your code, it sends a copy of the source code to a log file, so I can look at your source code. So echo $10 - 5. Right, that works fine. So some people, instead of using echo, they're using printf. Okay, printf is a command you can use inside bash. Right, I could say printf $paren 10 - 5, and it prints out a 5. Right, doesn't put a new line at the end, but you can, you know, do a backslash. Well, don't worry about that. But printf is not the same as echo. Okay, well, for one thing, it doesn't put the new line at the end. But echo $-10 times 2 gives you -20. Printf $-10 times 2 gives you an error. Right? Why? Because printf is seeing that hyphen and it's thinking that that's a switch, and it's looking for some special meaning, some modifier to the printf command, and 2 is not a valid modifier. Okay? I don't expect you to know that. I didn't know that until I played with it this morning, right? But if you know the echo command, right, then this is just kind of a landmine sitting out there that you're not going to run into. Yeah?
What's the modifier for echo that removes a new line at the end of the statement?
I think it's either -p or -n.
Okay.
-n. And man echo will tell you that. Do not put trailing new line. All right, so that's an example of the thing I was alluding to yesterday, which is there's lots of ways to do things, and sometimes some of these things will work in some cases, but not in others. So in the assessment for this ODP, one of the cases it tests is using a negative number. And if you didn't happen to think of using that when you were testing your code yourself, you wouldn't notice that printf doesn't work with a negative number because of the dash. So just things to keep in mind. All right, so let's make a script. Here's a script that says hello. And when I say go, it says hello. Big deal, right? All right. Let's talk about how we modify the behavior of a program or a script. We know that we can use the read statement. We can say read variable, and it'll wait for us to type something in, and whatever we type in, that becomes the value of the variable. So we're going to use the following terms a lot in this course, and there's usually some confusion around this, so I want to be really clear what I mean by these two terms. Okay, user input is the case where you do the following. You run your program, and the user types some input. That's why I call it user input. And then the program does something. So the ODP that you turned in this morning, what did that script do? You run the script, the user types in a number, and then the program prints out 2 times that number. Okay, that's an example of user input, and it's one way for the user to specify something to a program. There is a second way, and the second way is to use what we call command line arguments. And with command line arguments, what happens is you run the program, but you specify some information on the same line That's a poor way to put it. You specify some information when you're asking to run the program. For example, when you edit a file, what do? You say vi main.c. Okay, here would be what vi looked like if it was using user input. You would say vi enter, it would say what program do you want to edit? You'd say main.c enter, and it opens up main.c. Or when you compile, you would say gcc enter, and it would say what program do you want to compile? And you'd say odp.c, and it would compile it. Okay, that would be the user input mode. The command line argument mode is what we're used to. We don't say what we just said. We say vi space main.c, right? It's on the same line at the same time when we're specifying the name of the program, we're giving it some information, and it goes ahead and it acts on that. Or if we want to compile a program, we say gcc, and we tell it the name of the program, and then the program. Right, so it's another way to specify information to the program, but we don't do it while the program is running. We do it when we're asking the program to run. Okay, we put it on the same line as the command, so command line arguments. So the read statement, that's great for doing user input. Program's already running, it says read username, and it waits for the user to type something in. That's the value of username. But we can also do command line arguments. Okay, so demo of command line arguments. So how do we get to the command line arguments? Very, very simple in bash. In bash, we can just use the variables $1, $2, $3, and this will be the first argument, second argument, third argument. How do we do this in C? What's the general stuff we have to deal with if we want command line arguments in the C program? argc, argv, all of that stuff. Car star star, blah blah blah, yuck, right? Bash script is really simple. $1 is the first command line argument. So let's play with this. Let's just print out a message with echo $1 equals, and let's print out the value of $1. So if I say go hello, $1 is hello. Super simple. And if we print out the first three arguments, if I say go, hello there, bye, I can pick up those individual arguments. Yeah?
What's hello? Where's hello from?
So it's just a string of characters. If I had said, right, it has no particular meaning. It's just whatever I put after the name of the program, the first thing I put up to a space, that becomes the value of this variable $1.
So if you don't put anything, then the first hello will come out.
If we don't put anything, then $1 is just blank. It doesn't have a value. And if we say go Nick, $1 is Nick, and there's no second argument, so $2 is blank, $3 is blank. So that's an easy way to grab arguments from the user, from the command line when they run a program. Other questions about that? Not effectively. Probably if you get into the gazillions, yeah, but. All right, that is sufficient for us to do ODP 404. So let's look at 404. Alright, so 404 is another script. And it's a script that takes two command line arguments. The first is just some word. And the second is a number. And what your script does is it prints that word a certain number of times. Right? The number of times is whatever that second argument was. So let me give you an example. Alright, so you can assume that the word and the number will be present. Don't worry about the case where the user forgets one or both of them. So if I try to run my program without arguments, it can blow up, it can delete my files, whatever. Okay, it'll actually delete your files. So 404 and give it a word, I don't know, word, and give it a number 6. It should print out that word 6 times. Okay, that's the whole requirement for your ODP. 404 blah blah 2, it should print blah blah twice. So how do you do this? Well, you can find the word because it's in a variable called $1, and you can find what that number is because it's in a variable called $2 because it's the second argument. So make a while loop. Initialize a variable, and while that variable is, so if you initialize a variable to 0, you can say while that variable is less than $2, and then echo $1, set that variable equal to variable plus 1, you know, in the $paren, and that's the end of your while loop. Or you can use a for loop. And there's examples of both in that if, while for cheat sheet that's on bash, the one we looked at yesterday, right? And I don't care if you use a for loop or you use a while loop, but you need some kind of loop. So questions on how to do this? So this is due tomorrow morning at 8, and then I'm not giving any ODPs over the weekend. Okay, so if you do it before midnight, technically you don't have to do anything on the weekend. So it's a shell script, and you know, test it like this. And the one other trick is, if the number is less than 1, your script shouldn't print anything. Okay, so if I say 404, blah blah, and I say 0, it should produce no output. If I say -10, it should produce no output. And again, if it does anything other than this, it'll assess as a 0. If you say your value was not bigger than 0 exiting program, it'll assess as a 0. Okay. So if it's less than 1, don't produce anything. If it's n, print out that first variable, that first argument n times and exit. Doable? Cool. All right. So cowsay-f goose is now available. So if whoever created that wants to out themselves, you can take credit for it. But someone posted this last night. So cowsay-f will take a lot of creatures after it. And instead of a cow saying something, you can get a goose saying something. So that was supplied by one of your classmates. So I put it on the server. All right, good on ODP. I posted the ODP grades for the first 3 ODPs this morning. So those are up on Canvas. All right, let's talk about PA1. So this is your longer term programming assignment. And it's going to be a shell script, not surprisingly. And it's going to be a game. So it's a matchstick picking game. And you may have played this before. Basically, two people play the game. You start with a pile of sticks, and you take turns picking sticks. And you're allowed to take either 1, 2, or 3 sticks each turn. And the goal is to be the player who picks up the last stick in the pile. If you pick up the last stick, you win. And so you can play this like as follows. Stick. Okay, welcome to my matchstick game. How many sticks would you like to play with? And you can play with any number of sticks you want. 10 or above, I think the assignment says. So let's play with 15 sticks. And you get to pick who goes first, the user or the computer. So U for the user, C for the computer. So let's let the computer go first so that we can see how to play. All right, the computer will go first. Each turn, a player can take 1, 2, or 3 sticks. Whoever takes the last stick wins. Good luck. The initial pile, there's a picture of the 15 sticks, and it shows you the number of sticks, 15, so you don't have to count them. And it says, I take 3 sticks. The remaining pile is 12 sticks. So how many sticks should we take?
3.
3, okay. Remaining pile is now 9. The computer takes 1 stick. The remaining pile is 8. How many should we take? Remaining pile is 4. How many sticks should we take? So we'll take 2. And it takes 2 sticks. The remaining pile is empty. The computer won. Alright, so that's your goal, is to make a script that does this. And there's some requirements. So if you try to take an illegal number of sticks like 0, it should call you out on that and then ask you how many sticks you want to take. It's like, okay, I'll take 3 sticks. And if you try to take an illegal number of sticks that's bigger than 3, it should call you out on that. If you try to cheat 2 times in a row, it should give up and you lose by default because you cheated twice in a row. If you cheat once and then you make a legal move, you can cheat again and then make a legal move and then cheat again and make another legal move and so on. But if you cheat 2 times in a row, it kicks you out. Okay, so lots of logic processing that has to go on in here. And if you start with too few sticks, it will say you got to put in at least 10 sticks. And it will not give up after any number of bad entries there. Okay, it will keep asking until you put in a valid number. Okay, let's play with a bunch of sticks, and the computer can go first. Okay, impractical, but it should handle whatever. All right, so here's the long wordy version of that. You run the program just by saying stick, no command line arguments. Everything is user input here. Okay, greet the user, tell them what's going on, ask them how many sticks to play with. Make sure it's a number bigger than or equal to 10. Ask who goes first, computer or user. Oh, so stick, let's play with 20 sticks. Who should go first? Ha ha ha. Must enter U or C. Okay. If they don't type in a U or they don't type in a C, tell them they've got to enter a U or a C and keep going. Right? And just keep doing that until they make a valid choice and then start playing the game. Alright, after each move you should show the set of sticks and then show the number of sticks in parentheses, so like this for example. And when the computer makes a move, show the pile of sticks after that. When the user makes a move, show the pile of sticks after that. Okay, so that the user can really easily see how the game is playing out. Alright, illegal moves, this is what we just showed. If you make an illegal move, call them out on it. If they make a second illegal move right after that, kick them out. All right, so how do you write this so that you win? It's pretty simple. You'd always like to have a multiple of 4 sticks in the pile. If there's 4 sticks in the pile, and it's the user's move, they can take 1, 2, or 3. Whatever they take, you can take the remaining sticks. So your goal is make sure that when it's the user's move, the number of sticks is a multiple of 4. If you can guarantee that, you can win the game. On the other hand, if the user can do that to the computer, the user can win the game. All right, it's got to be written as a bash script. Make your backups, push this over to Git, right? So I would say when you first start this, go through everything you did for homework 1, right? It should be simpler. Your SSH key is set up. You're used to doing some Git stuff. So create a new directory, make a README maybe, or make your initial script. Git init, git add, git commit, git remote origin, git push. Okay. And that will make a copy of the repository on GitLab, and then after that, you just got to do git add, git commit, git push every time that you want to make a backup. So make backups, comment your code, okay? So $sign starts a comment. Anything that's not absolutely crystal clear obvious why you're doing it should get a comment on it, okay? Sticks equals sticks minus n. Comment, keep track of the number of sticks after that move. N sticks were taken, adjust the number of sticks. Something like that, all right? It's obvious to you why you're doing sticks equals sticks minus n, but it's not obvious to somebody else looking at your code, and it's probably not obvious to you next year when you're at a university and you're trying to resurrect this code because it was useful for something else, and you're like, I don't know what I'm doing in here. This was like so long ago. Okay, so put comments in. And in particular, you need to have a block of comments in the beginning of your program, what I call I don't have a name for it, comment block in the beginning that lists your name. I can't tell you how many programs I get turned in without any names in it. Okay, put your name in it. It's your work. Be excited about it. Put your name, the course, CSE 224, the date, the assignment number, and then in your own words, a description of what this code does. Okay, don't just copy and paste this, but you know, this is a stick picking game. It uses modular arithmetic, blah, 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 right? Put that in the beginning, and I'm going to be absolutely insistent this time. If I don't see that block of comments in the beginning with your name, a description, and so on, you get a 0, okay? So put that in first thing, right? First time that you write, if you can put that in and then just go ahead and make your Git repo from that, and then just add your stuff below it. But make sure the shebang is the very first line of the file. Don't put it after the comment block. All right, submit via Git. Use the same username that you supplied in homework 1 because now I've got those linked to your Canvas names. Make a repository called PA1, uppercase PA, digit 1. Make sure that you add me as a reporter, okay? And just make sure you push the version that you want graded over by the time this is due, which is next Friday, 8 a.m. All right, so the ODP starting next week, we'll start working through some of the details of this, but start thinking about how you're going to do this. Start thinking about the algorithm, okay? Don't start with shell script writing yet. Think about the algorithm, okay? And then on Monday, we're going to talk about conditional statements, which are also in that cheat sheet. It's no harder than writing a while loop. If, bracket, bracket, space, condition, space, bracket, bracket, then stuff you want to do, and then the closing bracket is FI, it's if spelled backwards, phi. That's an if statement in bash. All right, questions on this for 25 seconds. All right, so Monday we'll talk about ifs. Monday we will talk about the service learning project. And we'll take questions on this, and then we'll talk about the next ODP that'll be due.